The video notes for Unit 6, Lesson 2 will cover kinetic molecular theory. So remember, the notes for Lesson 1 are only in your digital notebook. So Lesson 1 was just a review of solids, liquids, gases. So you'll just complete the activities in the digital notebook for Lesson 1. But Lesson 2, you will actually need your printed out notes packet or a notebook of some sort to write down some terms and examples. So after the notes for Lesson 2, you should be able to describe the properties of a gas based on the kinetic molecular theory. So I'm going to present this quick. So make sure you have your notes packet ready to go. This is in section 13.1 of your textbook if you need a reference. So the kinetic molecular theory has three assumptions. So the first, in the kinetic molecular theory, we will talk about just in terms of a gas. So gas particles are in constant random motion. So that is one assumption of the kinetic molecular theory. So remember, kinetic means movement. So it's talking about the movement of these gas particles. So gas particles are in constant random motion. You can also assume that there are no forces between gas molecules and that the volume of the gas particle itself does not, it's insignificant. It does not affect the volume of the container. So when we talk about volume, we're only talking about volume of the container. We're not talking about the volume of the actual gas particle. And the third assumption is that the collisions between these particles are elastic. And elastic means no energy is lost or transferred. So as these gas molecules are colliding, they're not losing any energy, they're not transferring energy, they are just, the collisions are elastic, so they're just bouncing off of one another. So those are three assumptions that we will use for gas molecule movement as we discuss how these variables of a gas relate to one another. So here are a few terms that you'll hear used for gases. So gases have a property called compressibility. So gases can be compressed. Compressed means to squish down or to be, pressed together. So gas particles can be pressed together, and that is because if you compare solid, liquid, and gas particles are farther apart. They fill the space of the container, so there's more space for them to be pressed together. So gases are compressible. Another term that we'll define is gas pressure. So when we talk about pressure, we're talking about the force that the gas exerts on the walls of the container. So the force that those gas molecules exert while they're colliding with the container. So when we talk about pressure, pressure is a force. A vacuum, so this is a vacuum bell jar. We'll do some demonstrations in class that deal with this. But basically this pulls out all of the air inside that bell jar. So a vacuum is a space where there is little to no particles of matter. All right, another term that you'll see is atmospheric pressure. So atmospheric pressure is the pressure exerted by the Earth's atmosphere. So we have atmospheric pressure pushing down on us all the time. As you can see, this container of mercury, the atmospheric pressure is pushing that pool down, which then is causing the mercury to rise in the tube. And this is actually how a barometer works. Whoops. So a barometer would be this instrument here, which measures atmospheric pressure. So when the pressure is higher, there's more air pushing down on this, which is going to make the mercury in the tube rise. And when there's lower atmospheric pressure, there's less pressure pushing down on this, which then is going to cause the mercury in the tube to go down. So atmospheric pressure is the pressure from the gas particles in the atmosphere. and a barometer is the instrument used to measure that. All right, and then temperature. So we talk about heat and temperature. We'll talk about more with heat later on, but temperature is a measure of the average kinetic energy of the particles. So temperature is how hot or cold something is, but to measure that, we have to look at how fast all of the particles are moving and get an average reading of the kinetic energy. So remember, if I'm going too fast, you can always pause the video. All right, so another term that we've talked about last unit was STP. STP is standard temperature and pressure. These are the conditions, if you remember when we talked about moles, that 1 mole of any gas takes up 22.4 liters of space. That has to occur at STP. For this unit, the conditions will not always be at standard temperature and pressure. The temperature and pressure values will change, but these are those standard values. So standard temperature is 0 degrees Celsius. When we do gas law calculations, this is important. You might want to add this highlighted piece to your notes. All calculations that you'll do this unit, you have to have the temperature in Kelvin. So temperature scales, we have Celsius, Fahrenheit, and Kelvin. Kelvin temperatures do not have a negative value. So this is why we want to use Kelvin, and it also has a more direct relationship with Celsius temperature, or with, pressure and volume. So we'll always convert our temperatures to Kelvin. So if you're given a temperature in Celsius, you simply add 273, and that will give you your Kelvin temperature. So if the temperature is 15 degrees Celsius, you would add 273, so we would end up with a temperature of 288 Kelvin. So all calculations that you'll do this unit, you have to have your temperature in Kelvin. And then for standard pressure, there's actually 3 different units that you'll see. These are all equal values to each other. So 1 atmosphere, which is ATM, is the abbreviation. 101.3 kilopascals, the abbreviation is KPa. And then 760 millimeters of mercury, and the abbreviation is mmHg. So those are the 3 values for standard pressure. All right, one last thing for the notes for today for lesson 2 is the relationship between temperature and kinetic energy. So if you remember, when you heat something up, the molecules start to move faster. When they're moving faster, that causes a greater kinetic energy. So they have more kinetic energy. Remember, kinetic means movement. So at a low temperature, the molecules are still moving, but not very fast. When you heat it up, that's when those molecules really, really start to move fast. So the greater the temperature, the greater the kinetic energy. So that is it for the notes for lesson 2. As always, let me know what questions you have.